Hello. Today we are going to be reviewing solving equations with variables on both sides for one solution, infinitely many solutions, and no solution. So when you get an answer that only has one solution, that means that your final answer will result in the form of x equals some number. And there's only one real number that can make this equation true. So let's do an example. So first thing here is I have to simplify by doing my distributive property over here on the left. So 2 times 2x, so 2 times x is 2x, and then 2 times a negative 3 is a negative 6, and then you still have a plus 9. Here, let me get a different paper. So 2 times x minus 3 plus 9 equals 5 plus x minus 1. Sorry, the copier machine did that, so we'll just do it on here. So again, you're doing your distributive property, so 2 times x is 2x, 2 times a negative 3 is a negative 6, and then you still have your plus 9. Okay. Next step is to combine like terms that are on the same side. So here I can combine a negative 6 and a positive 9 to get a positive 3. And then over here on the right, I have a positive 5 and a negative 1, so I can combine those together to give 4. Okay, so once everything is simplified, I can now start moving my x's to one side and my constants to the other. So the opposite of adding x is subtracting x. 2x minus a 1x would just leave me with x, and then I still have a plus 3 equals 4. And then our last step to get x by itself is to subtract the 3 from both sides, so we get an answer of x equals 1. So this is one solution because our end result was x equals some number. So the number 1 is the only solution that will work to this problem. Okay? Alright, moving on to infinitely many solutions. So for infinitely many, the final answer will result in the form of the same number equals the same number. So like 1 equals 1, 2 equals 2, or whatever it is. So any real number can make the equation true. So no matter what number you plug in for x, it will make a true statement. Okay, so let's do this together. So again, first thing I need to do is simplify. So I'm going to take my outside number and I'm going to multiply it times everything on the inside. So 2 times x is 2x, 2 times 10 is 20. Bring down my minus 17, and then I'm going to leave this over here for now, so 5 plus 2x minus 2. After you get rid of the parentheses, you can now start combining your like terms. So I see that I have a 20 minus a 17, so that would give me a positive 3. And then over here on the right, I see a positive 5 and a negative 2, so if I combine those together, that again will give me a positive 3. So from this step, I know right away that I'm going to get infinitely many solutions because I have the same thing on both sides. I have 2x plus 3 equals 2x plus 3. But I'm going to continue to solve it just so that you guys can see the format of a equals a. So move your variables to the same side. So I'm going to move the 2x over here. And notice when you do that, that both of your 2x's are going to cancel because that equals 0. And you're just going to be left with 3 equals 3. So a equals a. And if you get the same number on both sides, so the same thing on the left side and the same thing on the right side, this means you get infinitely many solutions. And you have to write that. Okay, and then the last one that we have talked about is no solution. So when you get an answer that has no solution, that means that your result will end in the format of a equals b, where a is a different number than b. So there is no possible answer for this equation. Okay, so let's do a couple of examples here. So again, as soon as you see those parentheses, you need to do your distributive property. I'm going to leave the left side alone for right now. So 2 times x is 2x. 2 times 3 is 6, and then we still have a minus 5. Now I can start combining my like terms, so I see a 5x and a negative 3x. So 5x minus 3x is a 2x. And then over here, I can combine my 6 minus my 5, and that will give me 1. And then again, guys, from here, I know that I'm going to get no solution because I have the same coefficient, different constants. But I'm going to go ahead and finish solving this just so that you guys can see the A equals B format. So again, first thing is to move your variables to one side. And again, your two x's are both going to cancel out because they equal 0. So all that you're left with is 3 equals 1. And that is not a true statement. A does not equal B. So if it's not a true statement, that means you get an answer of no solution. Okay, and then at the bottom of this paper, I do like the diagrams that they give us. So if you get something with no solution, that means you don't have the same thing on both sides. Like our answer was 3 on the left and 1 on the right. So your scale is not even, so that means you have no solution. When you had infinitely many solutions, that means that you had the same thing on both sides. So we had 3 equals 3, and then 2 x's on both sides. So again, your scale was equal and they both equaled the same, so that means you have infinitely many solutions. And then I know that this one's hard to see, but this is where you would get x equals some number, because your scale is still the same, they're still equal, but you don't have the same thing on both sides. Okay? Alright, so just a couple more practice problems on the back here. And let's see what kind of answers we get. And if you guys want to try these on your own, you can go ahead and pause the video and try them on your own. But I'm just going to go ahead and complete them. So first thing to do here is the distributive property. So you're taking 4 times x, which is 4x. 4 times 3, which is 12. And then you have your minus 4. I know this is hard to see again, so I'm just going to do it on here. So we have 4x plus 12 minus 4. And then over here on the right, when you distribute, 8 times a half x is 4x. And then 8 times 1 is 8. Noticing the left side, I can still combine like terms of my 12 minus 4 here. And that will give me 8. So looking at both sides here, notice how I have 4x plus 8 equals 4x plus 8. So I have the same thing on both sides. So if you guys want to go ahead and stop and write infinitely many solutions, you can. Or if you need to take it that extra step by subtracting your 4x's to see that those cancel, and you get 8 equals 8, that's fine, okay? But you need to write infinitely many solutions. Okay? And then looking at number 4, so again, I'm going to do this on my scrap paper. So we have 3 halves times 2x plus 6 equals 3x plus 9. Okay, so again, parentheses, to get rid of them, we have to do our distributive property. So 3 halves times 2x will be 3x, and a 3 halves times a 6 will be 9. And then over here, we're going to have that 3x equals 9 again. And then again, as soon as you get to this point, and you realize that you have the same thing on both sides, you can go ahead and write infinitely many solutions. If you need to take that extra step by subtracting the 3x's from both sides to see that you get the solution 9 equals 9, then that's fine, but your final answer is infinitely many solutions. Alright, and then our last problem here, number 5. There's no parentheses, so I don't have to do the distributive property. However, I can combine like terms. So on the left, I see a 3 and a 4 that I can combine. So that will give me a positive 7. And on the right, I can subtract these, the 4x minus 5 halves, because they are the same like term. They have the same variable to the same power. So 4x minus 5 halves, x is 3 halves x. And again, from this statement, I know that I'm going to get no solution because I have the same coefficients, different constants. But again, if you need to take it all the way down to see what kind of answer you get, that's fine. So to get your x's on both sides, you're going to subtract your 3/2 from both sides. 3/2 minus 3/2 is 0, so both of those are going to cancel. So you're still left with 7 equals. And then since you have nothing over there, you're just going to put a 0. So since 7 does not equal 0, your A does not equal B, this means that you have no solution. Okay? So then the last part down here at the bottom is they want you to draw lines to match each linear equation to its correct number of solutions, and how can you tell when an equation has no solution or many solutions? So again, when you have no solutions, that means that you have same coefficient. I was going to put same coefficient, different constants. When you have infinitely many solutions, that means you have same coefficients, same constants, and then one solution, you just have different coefficients and your constants do not matter. So remember, your format of no solution is A equals B, so that means that you have different numbers. Infinitely many solutions means that you have the same number on both sides, so A equals A. And then one solution means you have x equals some number, so you just have one number that equals itself. Okay? So really all that we need to do is simplify these and then figure out where does it belong. So if I were to do my distributive property here, 5 times 4 is 20, and then 5 times the negative x is the negative 5x. And then over here on the right, that is already simplified. So we're just looking for the characteristics here. So look at your coefficients. So those are numbers attached to variables. Notice how I have -5 and -5. So I have same coefficients. So that rules out one solution. And then you go to your constants. So the constants are numbers without variables. So I have two 20s here that are the same. So I do have the same thing on both sides. So I have A equals A. So that means that this will have an answer of infinitely many solutions. And again, you can keep solving it if you would like to. So just add your 5x's to both sides. And that would give you a 20 equals 20. So A equals A. Okay. So let's do the next one. So now it's a -5 out front. So a -5 times 4 is a -20. -5 times the negative x is a positive 5x. And then over here on the right, we would get a -5x plus a 20 again. Okay, so again, look at your coefficients first. So my coefficients, I have a +5 and then I have a -5. So they're not the same. One's positive, one's negative. So if you don't have the same coefficients, that's your indicator right away that it's going to give you one solution. And then again, you can keep solving it if you would like. So add your 5x's. That gives you a -20 plus 10x equals 20. Move the 20, so then you get 10x equals 40, divide both sides by 10, and you do get an answer of x equals 4, so that is one solution. Okay, so that means that this last one should be no solution, so let's see. So do your distributive property to simplify. 5 times 5 is 25. 5 times a negative x is a -5x. And then on the right, we're going to keep our -5x plus 20. So again, first look at your coefficients. We have negative coefficients. So then you move to your constants and notice how these are different. So if you have same coefficient, different constants, that means that you are going to get no solution. And again, you can keep solving it. So add your 5x's to both sides. And as soon as you see that your numbers do not equal each other, so you get like A equals B, that's your indicator that it's no solutions. All right, so this was just a quick review over solving equations with variables on both sides and getting special cases as your answers. So just let me know if you still need any help.